question 100 in your homework was as follows. Aspirin is produced from salicylic acid and acetic anhydride. And they give you the balanced equation in the book. So you don't have to balance it, it's already balanced. The stoichiometry is 1 to 1 to 1 to 1. A, how much salicylic acid is required to produce 1.5 times 10 to the 2 kilograms of aspirin, assuming that all of the salicylic acid is converted to aspirin. So in the first question, they're assuming the reaction goes 100% to completion. This is the procedure we normally follow for solving stoichiometry containing reactions. We start off with grams of something, divide by the molar mass to find the moles of the substance, and then we go through the stoichiometry to find moles of the other substance, and then we convert back to grams of the other substance by multiplying by molar mass. So there's 7 discrete steps that we have to go through. This is the reaction. Salicylic acid reacting with acetic anhydride gives you acetylsalicylic acid, known as aspirin, and then one of the byproducts is acetic acid. So we're told that we start off, we want to achieve the synthesis of 150 kilograms of aspirin. So we're going to convert our 150 kilograms to a quantity we can use in a calculation. So we're going to multiply it by 1,000 to give us how many grams that is. That's 150,000 grams. So that's the first step of our calculation. We found out how many grams. Then we always go to moles. All these reaction calculations, we always go to moles to find out, so we can equate with the other quantity in the same equation. So we're finding moles of acetylsalicylic acid, and then we're going to equate it to how many moles of salicylic acid are necessary to obtain the 150,000 grams of acetylsalicylic acid. I divided the molar mass I divided this 150,000 grams by the molar mass of acetylsalicylic acid to find out how many moles of ASA we have, and that's what we find out over here. That's the third step. So this number 2 is dividing by molar mass. The molar mass of acetylsalicylic acid is obtained by multiplying by 9 times the molar mass of carbon, 8 times the molar mass of hydrogen, and 4 times the molar mass of oxygen, because that's what appears in the formula. Okay? That's where those numbers are coming from. That adds up to 180 grams per mole. You have 150,000 grams of the stuff. It weighs 180 grams per mole, so that's how many moles you have. All right? We found out the moles. We're at step 3 now. We found out how many moles of ASA. Now we've got to equate the amount of ASA into the amount of SA, and we know that it's 1 to 1 from the balanced equation. That's 1 and a 1. So 1 mole of salicylic acid will produce 1 mole of ASA. That means we're going to need the same amount of moles of salicylic acid if the reaction proceeds 100%. And that's what we've done here. That's step 5. Step 4 is the stoichiometry, which is 1 to 1. Very simple in this reaction. The next step is to convert from moles of salicylic acid to grams of salicylic acid. And to do that, we have to multiply by the molar mass, as it says here. Step 6 is to multiply by the molar mass of the other substance, which in this case is salicylic acid. So salicylic acid contains 7 carbons, 6 hydrogens, and 3 oxygens. So 7 times the mass of carbon, 6 times the mass of hydrogen, 3 times the mass of oxygen is going to give you a molar mass of 138, which you then multiply by the number of moles of salicylic acid. So that many moles, 832 moles of salicylic acid, at 138 grams per mole gives you 1.15 times 10 to the 5 grams of salicylic acid, and then we convert it back to kilograms. It gives us 150 kilograms, 115 kilograms. We're only allowed 3 significant figures in our answer, so that's what we report. In the next question, in the next part of the question, it asks how much salicylic acid would be required if only 80% of the salicylic acid is converted to aspirin. So we want to obtain 115 kilograms, but our reaction is only 80% efficient. So we're going to divide by 0.8 to make that number bigger, because that's what we're going to have to pour into it to get this amount of product. And it comes out to 144 kilograms if we have only 80% efficiency. Any questions?